Now we're going to take what we've learned with our powers of 10 and we're going to use this new thing called scientific notation. Wish I had a cool voice changer there. So what other class do you think we're going to see scientific notation in? Science, exactly. We use scientific notation to use these powers of 10 that we've been talking about to represent really, really big numbers and really, really, really small numbers. It's like how heavy is the sun? How small is an electron? Those types of things we use scientific notation for. So we're going to see how scientific notation is related to powers of 10. We're going to look at what we need to consider when we're comparing numbers in scientific notation. Again, be thinking about those exponents and what those exponents mean. By the end of this, I can recognize powers of 10 with positive and negative exponents by examining patterns, and I can represent powers of 10 with negative exponents in decimal and fraction formats. Both of these skills from powers of 10 are going to be important with scientific notation. So let's take a look at it. So, scientific notation is a shorthand or an easy, shorthand means easy, way of writing numbers that are often very small or very large by using powers of 10. Powers of 10, remember power means exponent. Power means an exponent. So the way that we see scientific notation is some number A. A is greater than or equal to 1 and less than 10. If it equals 10, I can make it even easier. I can make that 10 into a 1, but it's somewhere between that 10 and 1. 10, remember, is that big number with the exponent. What's the big number called? Starts with the letter B. 10 is my base, and n is my exponent. And like we saw with powers of 10, it can be positive or negative. It just depends on if it's a really, really big number, we have positive, or if it's a really, really small number, we have a negative exponent. Again, very large numbers use positive powers of 10. So the example that they give here, this is a number written in scientific notation. It says 3.5 times 10 to the 7th power. That's the scientific notation way to write 35 million. It's a lot shorter to write scientific notation than it is to write 35 million. And then we also have very small numbers that use negative powers of 10. So 3.5 times 10 to the negative 7 would be 35 10 millionths. 35 10 millionths. Place value is important here. We have tens, hundredths, thousands, 10,000s, 100,000s, millions. Ooh, girl, did I count right? Tenths, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. That's 3,500 millions. That's a lot. That's very small. Very, very small. So that's why we use positive for big numbers, negative for little numbers, because negatives make some decimals. So let's go on and do some practice problems where we're converting back and forth between standard notation, that's where we see the really big numbers, those decimals, and scientific notation, where we see some number times 10 to an exponent. All right, so when we're converting from standard, the normal way, to scientific notation, the first thing we need to do is find the decimal. We're not always going to see the decimal, because math people, we're not always going to write it. We're not always going to write it, especially if we don't have to. Like for this number. Sorry, let me get this all figured out. There we go. There we go. 547,700. Math people, we're not going to write that decimal at the end usually, but that's where it is. In a decimal number, it's really easy to see where it is, where it starts. So first thing, we got to find that decimal. Then we need to move the decimal. We're going to move the decimal to the left for larger numbers, and we're going to move it to the right for smaller numbers. Because again, the goal is to get this number so that the decimal place makes it between 1 and 10. So if my decimal starts here, I need to move it, move it, move it, move it here. Now it's 5.477. 5.477. Now it's between 1 and 10. On my decimal, I want to move it, move it, move it, move it here. I made my number 2.5. 2.5 is a decimal between 1 and 10. Step 3 is what we just did. For all numbers, we need to move the decimal so there is 1 digit before it. We moved it so there was 1 digit before it. So here we moved the decimal to make it 5.4. So now we have 5.47700. Here we moved the decimal. So it's just a bunch of zeros and then 2.5. We're making this decimal between 1 and 10. Again, if it's 10 and we can make it smaller, we can make it 1. Then we want to drop any unnecessary zeros. Like these zeros at the end, those don't matter to us. These zeros out here out front, those don't matter to us. So now we just have 5.477 and just 2.5. Now we need to add our times 10 to some exponent, to some number. For large numbers, numbers greater than 1, we want to use positive exponents. For small numbers less than 1, we use our negative exponents. The exponent is the number of times that we jumped and we moved our decimal. So if we come back up here, we jumped 1, 2, 3, 4, 5 times. So our exponent is going to be a 5. So our final number, it's kind of hard to see there. I'm going to write it again. It's going to be 5.477 times 10 to the 5th power because we jumped the decimal 5 times. Over here, our decimal was 2.5 times 10. Our exponent's negative because it's a decimal. Because it's a small number, our exponent's going to be negative. And our decimal jumped 1, 2, 3, 4 times. So that's going to be 10 to the negative 4th power. If you need to pause, rewind, go back, see that again, please do. Please do. Otherwise, I'm going to move on to the next section where we go from scientific notation into standard form, back to the normal way that we're used to seeing our numbers. So to convert back to standard notation, again, we want to start off finding the decimal. Start off by finding the decimal. So for example here, 6.26 times 10 to the 6. We found our decimal. And then we want to use the exponent to see how many places we move the decimal. Now these directions are going to be kind of opposite. If we had a positive exponent, would that be a big or a small number for a positive exponent? That's a big number. So am I going to move this decimal point to the right or to the left to make it a bigger number? We need to move it to the right to make it a bigger number. Here, our decimal is 1.54 times 10 to the negative second. That's a small number, so we need to move the decimal to the left to make it smaller. Like I said, it's opposite from what it was before. Positive, we move it right. Here we moved it to the left to make it in scientific notation because we need to make it smaller. So think, when you're moving your decimal, which way should I move it to make my number bigger or smaller depending on my exponent? So for our first problem, we have 6.26 times 10 to the positive 6. Because it's positive, we move our decimal to the right 6 places. So 6.26, we move it 1, 2, 3, 4, 5, 6 spots, and then we drop our decimal. What do you think is going to go in those open jumps to hold place value? Zeros. So we're going to fill in those jumps with zeros. What was my exponent there? 6. So we moved our decimal 6 times. Here, 1.54 times 10 to the negative second. Negative means we move to the left in 2 spaces because my exponent is 2. So we move it once, we move it twice, and now it goes here. And same thing, to hold a place value, we fill in that open jump with a 0. The exponent, common misconception. The exponent is not how many zeros there are. Here, my exponent was 6, but we have 4 zeros. Here, my exponent was 2, we have 1 0. You need to be careful. The exponent is not the zeros. The exponent is the number of jumps. The exponent is the number of jumps. And then like we already did, we filled in our empty spaces with 0. So 6.26 times 10 to the 6th is equal to 6,260,000. 1.54 times 10 to the negative second is equal to 154 10,000ths. So there was a real quick rundown of scientific notation. Take that quizzes to see how you do. See how you do and see if you need a little more practice, if you're just ready for more practice, or if you need a little more work with the notes. But please come find us. Let us know if you have any questions before you move on. Good luck.